Good afternoon, guys. So today we are going to be starting Learning Target 2, solving for trig equations. We are going to be solving these in radians. As you can see here, we're solving for all things between 0 and 2 pi. So that's telling us that we want our answer in radians. I'm going to go ahead and find all of our answers in degrees first, and then transform into radians, just because I think it makes a little bit better sense to most people. You can see here, this is just like an equation that we did back in ES6. First step we want to do is divide both sides by 2. So that gives me the sine of x is equal to 1/2. If you don't remember these answers offhand, you need to remember that we are looking in our coordinate plane. We need to remember all students take calculus. So where the sign is positive is going to be here in quadrant 1 and in quadrant 2. This is opposite over hypotenuse. So I'm going to label the opposite as 1, the hypotenuse is 2 in both of those triangles. So now if you did the Pythagorean theorem, you would find this side, 4 minus 1 is 3, so these are the square root of 3. That makes this a 30-degree angle in both triangles. So we would say that x is equal to 30 degrees or 150 degrees. Or in radians, 30 degrees is pi over 6. And then here, this is at pi. So 1 pi minus 1/6 pi is 5/6. So 5 pi over 6. That should be a good review of what we did back in ES6. Now we get a little bit more complicated. Our first steps here are always to get our x to one side. So I'm going to subtract the sine of x from both sides. So that gives me negative square root of 2 equals negative 2 times the sine of x. Now we want to divide both sides by negative 2. So I get the sine of x is equal to the square root of 2 over 2, which we remember from ES6 is the same as 1 over the square root of 2. So now I draw my coordinate plane. All students take calculus. I need the opposite to be 1 and the hypotenuse to be the square root of 2. So we're going to be here in quadrants 1 and 2 because the sign value is positive. If you did the Pythagorean theorem, square root of 2 squared is 2. 1 squared is 1, so 2 minus 1 is 1. That makes these 45 degrees. So we would get an answer of x equals 45 or 135. In radians, that is pi over 4 or 3 pi over 4. Question 3. Solve for x. You should be able to do 2 steps in one, so we would get the sine squared of x is equal to 3/4. Then I added 3 and then divided by 4. Next step, remember the sine squared of x is the same as the sine of x quantity squared. So to get rid of that square, I need to take the square root. So we would then get the sine of x is equal to the square root of 3 over 2, because the square root of 4 is 2. Now the thing that most of you have forgotten right now is that in Algebra 2, we learned that whenever you take the square root of both sides, we have to look at both the positive and negative of that answer. So I'm looking at the positive and negative of all those answers. So in my coordinate plane, I would have triangles in all 4 quadrants. And the opposite would be the square root of 3. The hypotenuse would be 2. that makes each one of these 60 degrees. So my answer for x in degrees would be 60 degrees, 120 degrees, 240 degrees, and 300 degrees. Or in radians, 60 degrees is pi over 3. So that's pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. On the next one, my first step is to get the variable to one side. So I'm going to subtract 2 sine of x from both sides. So I have the sine squared of x minus 2 sine of x is equal to 0. Last class we talked for a little bit about how we could use substitution. We used let u equal the sine of x. So then I could rewrite this statement as u squared minus 2u equals 0. Now all of a sudden this looks like an algebra 2 problem. In algebra 2 we would factor out the GCF of a u, so that would become u times u minus 2 equals 0. So then solving, we get u equals 0 or u equals 2. Scroll down a little bit here. I'm going to plug back in the sine of x for u. So where is the sine equal to 0? Well, remember our 4 points. This is the point 1, 0, 0, 1, negative 1, 0, 0, negative 1, and every point is cosine sine. So where the sine value is 0 is here at 0 and at pi. So this gives me x equals 0 or pi. That's in radians, of course. In degrees it would be 0 degrees and 180 degrees. For the second one, where is the sine of x equal to 2? Well, we remember the sine is here at the y values, so the highest value that my sine gets to is at 1, the lowest it gets to is at negative 1, so it'll never reach a high value of 2, so that doesn't give me any solutions. So my only solutions to this equation are x equals 0 and x equals pi. Okay, so we've got 2 problems left. On this next one, we're going to do the same thing. Just to help us out, we're going to start off with let u equal, let u equal the sine of x. Because that allows me to plug in, and I would have 2u squared minus 3u plus 1. So I replace sine of x with u, and here sine squared of x would become u squared. Now we can do bottoms up factoring. So 2 times 1 is 2. Factors of 2 that add up to be negative 3 are negative 2 and negative 1. Then we remember to put both of those over top of your a value. This simplifies to be 1, and this bottom comes up. So I get u minus 1 times 2u minus 1. Now when I go to solve that, I get u equals 1 or u equals 1/2. Replace the u with the sine of x, and we get the sine of x equals 1 or the sine of x equals 1/2. Now this is 2 problems that we need to solve. To solve the sine of x equals 1, I need to again look at my coordinate plane and remember all of my coordinates. 0, 1, 1, 0, 0, negative, 0, negative 1. I totally screwed that up. Sorry about that, guys. Let's try that again. 1, 0, 0, 1, negative 1, 0, and 0, negative 1. So these are cosine sine values. So I would have an answer here at 90 degrees for this one. So x equals pi over 2. And then for sine of x equals 1/2, I need to draw a new coordinate plane. I'm going to have triangles here in quadrant 1 and quadrant 2, because that's where the sign is positive. Opposite over hypotenuse. That makes this side the square root of 3. That makes these 30-degree angles. So my answers would be 30 degrees and 150 degrees, which in radians is pi over 6, or 5 pi over 6. All right, last problem. So the sine of 3x equals negative square root of 3 over 2. This time, I'm going to do the same idea. I'm going to let u equal 3x. So that gives me a new equation of the sine of u. The sine of u is equal to negative square root of 3 over 2. Well, that's pretty easy to solve. We have two triangles down here in quadrants 3 and 4, where the opposite is the square root of 3 and the hypotenuse is 2. Oops. So that makes this a 60-degree angle, and this a 60-degree angle. So u would equal 240 degrees or 300 degrees. So then if we set 3x equal to 240, we get x equals 80 degrees. Set 3x equal to 300, we get x is 100 degrees. And that's great, but what if I took an angle that was coterminal here to 240? So an angle that's coterminal to 240 would be 240 plus 360 is 600. If I set 3x equal to 600, I get x is 200 degrees. That is still between 0 and 2 pi, if I converted it to radians. So I need to consider that as an answer. Same thing over here. Coterminal to 300 is 660 degrees. So if I set 660 equal to 3x, I get x is 220 degrees. Well, what if I took it a whole nother round? So if I took 600 plus 240, I get 840. And if I take 660 plus 300, I get 960. Well, so set 3x equal to 840. X goes in there 280 times. Set 3x equal to 960. I get 320 degrees. You notice if I add 240 to 840, I get 1,080. If I take 1,080 divided by 3, I get an answer bigger than 360. So that is where my answers stop. So my answers are these degree measurements. Technically, since the answer says in radians, I'd have to multiply each one of those by pi over 180. I'm just not going to do that here in our notes. So that ends our notes. Please come up and grab the homework, and then you are done for the day. Thanks.